Welcome to this guide on Kubernetes namespaces. In this video, we'll explore how namespaces enable logical cluster partitioning, allowing you to organize and isolate resources effectively within a Kubernetes cluster. Namespaces are essential for managing multi-tenant environments and maintaining clean resource separation. Let's dive in and understand how namespaces can transform the way you manage your Kubernetes infrastructure. Kubernetes namespaces are virtual clusters within a physical Kubernetes cluster that provide logical separation of resources. Think of them as isolated workspaces where different teams or applications can operate independently. Namespaces serve three primary purposes. First, they isolate resources and workloads, preventing conflicts between different applications. Second, they enable multi-tenancy environments, allowing multiple teams or customers to share the same cluster securely. Third, they help organize and manage cluster resources efficiently, making it easier to navigate and control large-scale deployments. When you create a new Kubernetes cluster, 4 default namespaces are automatically created. The default namespace is used for objects that don't have a specific namespace assigned. This is where resources go if you don't explicitly specify a namespace. The kube system namespace contains Kubernetes system components like the DNS server, metrics server, and other critical infrastructure pieces. The kube public namespace is readable by all users and is designated for public resources that should be visible across the entire cluster. Finally, the kube node lease namespace holds node heartbeat and lease objects that help the control plane detect node failures and maintain cluster health. Creating a namespace in Kubernetes is straightforward and can be done in 2 ways. The quickest method is using the kubectl command line tool. Simply run kubectl create namespace followed by your desired namespace name, such as dev team. Alternatively, you can use a YAML manifest file for more declarative infrastructure management. The YAML approach specifies the API version as v1, the kind as namespace, and includes metadata with the name property set to your namespace name, like dev team. Both methods create the same result, but YAML manifests are preferred for version control and reproducible infrastructure. Once you've created a namespace, you'll need to know how to interact with resources within it. To deploy resources to a specific namespace, use the kubectl apply command with the -f flag for your manifest file, followed by the -n flag and the namespace name, such as dev team. To list resources in a particular namespace, use kubectl get pods with the -n flag and the namespace name. This shows you all pods running in that namespace. If you're working extensively with one namespace, you can set it as the default for your current context using kubectl config set context with the _current flag, and _namespace equals the namespace name. This saves you from specifying the namespace with every command. Namespaces shine in multi-tenancy scenarios where multiple teams or environments need to coexist. One common use case is environment separation. You can create distinct namespaces for development, staging, and production environments within the same cluster. This allows you to test isolated features without affecting other environments, maintaining a clear boundary between different stages of your application lifecycle. Another critical use case is team isolation. By creating separate namespaces for different teams or projects, you prevent accidental interference between teams. Each team can work independently without worrying about conflicting resource names or accidentally modifying another team's deployments. Resource quotas are essential for controlling resource consumption within namespaces. They define limits on the total amount of compute resources that can be consumed by all objects in a namespace. In this example, we create a resource quota object with API version v1 and kind resource quota. The metadata specifies the name as dev quota and the namespace as dev team. The spec section contains the hard limits, including requests.cpu set to 10 cores, requests.memory set to 20 GB, and a maximum of 50 pods. These quotas prevent any single namespace from consuming all cluster resources, ensuring fair distribution and preventing resource exhaustion. Network policies provide crucial network-level isolation between namespaces. They control traffic flow at the IP address and port level, defining which pods can communicate with each other. This example shows a network policy with API version networking.k8s.io/v1. The metadata specifies the name as deny from other namespaces in the dev team namespace. The spec section includes a pod selector that applies to all pods in the namespace and an ingress rule that only allows traffic from pods within the same namespace. This configuration effectively isolates the namespace from external traffic originating from other namespaces, creating a secure boundary around your workloads. Role-based access control, or RBAC, works seamlessly with namespaces to provide fine-grained access control. RBAC allows you to define who can perform what actions on which resources within a specific namespace. This example creates a role with API version RBAC.authorization.k8s.io/v1. The metadata specifies the namespace as dev team and names the role podreader. The spec section defines rules that grant permissions to the empty string API group, which represents core Kubernetes resources. It allows get and list verbs on pods resources. This means users assigned this role can only view and list pods in the dev team namespace without the ability to create, modify, or delete them. Let's wrap up with some best practices for working with namespaces. First, use meaningful naming conventions for your namespaces that clearly indicate their purpose, such as team name environment or project name stage. Second, always set resource quotas and limits to prevent resource exhaustion and ensure fair allocation across teams. Third, implement RBAC policies for access control to ensure users can only access resources they're authorized to manage. Fourth, configure network policies for traffic isolation to protect sensitive workloads and enforce security boundaries. Finally, avoid using the default namespace for your applications. Reserve it for quick testing only, and always create dedicated namespaces for production workloads. Following these practices will help you maintain a well-organized, secure, and scalable Kubernetes environment.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.